perfectly safe and perfectly intact. So we actually haven't had any instances of our own. Tanks are actually very safe.
I might just follow up. Yeah, I just want to add to that I think it's important to understand the physical nature of natural gas versus gasoline. Gasoline is flammable in the tank as it exists. Natural gas is lighter than air. Even LNG. And the other important thing to understand about natural gas is it will only ignite with a certain mixture of air to gas. So it's about 15%. Now, can you get that mixture in an accident situation? Yes, you can, if there's an ignition source right at that moment. So I'm not saying it won't explode, but it's important to understand that natural gas being lighter than air, when a release occurs, it dissipates. As opposed to gasoline, when a release occurs, it cools. And it's flammable right there, right at that instance. So physically, the fuel is a safer fuel.
It's true. However, we have never had any instance of gas release in any of those collisions that have taken place. So it's not as if it's a given that when you're in a collision or a tank is compromised, the gas will be released. In actuality, that's the extreme rarest. Yes.
Are these existing gas stations that are doing this? Are these a separate industry? Is there, how is this unfolding?
Sure. Natural gas fueling stations.
Can you repeat the question, please?
The question was, could I please comment on the retailing of natural gas as it occurs out in the marketplace? Who are the folks that are putting stations in? What do the economics look like? Is that correct? Okay. So the companies that are putting in natural gas stations are essentially experts at taking gas from the pipeline and looking at the dynamics there. Is there a pipe in the ground close by? What's the pressure in the pipe? And all the variables that exist with the retail location, the seismic concerns, the permitting concerns. Where is it? Is it in a rural area or in a city area? And then basically putting equipment on the ground there that can extract the gas from the pipe and compress it so that it can be dispensed into a vehicle. Traditionally, they're not gas stations that are becoming CNG stations. It's something separate entirely. And it's companies that have sort of built themselves around the expertise associated with building a natural gas fueling station and managing that value chain. The equipment that's involved in the natural gas station, the compressors, the dispensers, and so forth, is all very specialized. It's not gasoline equipment that is retooled to dispense natural gas. It's unique. And so there's certain companies that have done really well at vertically integrating themselves to own a compressor company, for example, and then they build stations, and then they own a dispenser company, or they're very well networked with a dispenser company. So they really have sort of become good at the entire value chain associated with dispensing the fuel. And they're also not...
Go ahead and identify one of those companies here on the West Coast.
Sure. Clean Energy Fuels is a great one. As you move east, you'll see, there's a company called Integris, which owns a company called Trillium. It's another large player with regard to putting in stations. And then there's some other smaller ones. Chesapeake Energy, for example, has just announced a large-scale plan to put in a number of stations. So the stations are also fairly expensive, and that's a barrier to putting one in. The cost to put in a fast fill station, and what we call fast fill is a conventional retail footprint gas station. There's other methods of getting gas in a vehicle, but fast fill is what we'll all identify with as a gas station. Those stations cost between $500,000, $750,000 to $1 million, $1.5 million to $2 million. Most full-scale retail stations, $1.5 million.
We've got a question in the back.
Yes, I understand now, at least with larger trucks, both in infrastructure and maybe in vehicles, that folks are now looking at liquefied as well as compressed. I was wondering if you could parse those two variations.
Yeah, absolutely. So the advantage, liquefied natural gas is essentially compressed natural gas that's refrigerated into a liquid, and it's far more dense than gaseous natural gas. One of the main advantages associated with liquefied natural gas vehicles is that the challenge that we face with compressed natural gas and storing it on a vehicle is eliminated. Natural gas is larger in terms of volume than a liquid. It's a gas, right? So it's less dense. So the amount of real estate you need on a vehicle to store the fuel is greater with a gaseous fuel. So by switching to a liquid, you have much greater energy density, and it becomes much easier to locate tanks actually on the vehicle. natural gas, since it's more dense, you can store a lot more fuel in a much smaller space, which is much more conducive to going great distances between infrastructure points. So it makes the most sense that if a large truck is going to haul goods from one major metro to another, that would be a liquefied natural gas vehicle, because it's easier to locate the fuel on the vehicle and there's a lot more fuel on the vehicle, so it can just go further. The difficulty with liquefied natural gas is that the infrastructure is even less robust than compressed natural gas. You have very limited amount of liquefied natural gas distribution hubs around the country. And so in order for that to be completely viable for trucks to go everywhere, there needs to be a lot more liquefied natural gas distribution points than there are today.
And in terms of the tank, is the cryogenics worse than the pressure?
Worse how?
Harder physically to keep it cold and to manage the pressure of gas.
It's similar, you know. I mentioned with compressed natural gas, the tanks are the most expensive component, so it's not any easier or more difficult. I would just describe it as different. Certainly the challenge associated with where you would locate tanks and getting the required amount of fuel onto the vehicle, that portion is much easier with LNG.
Now, if you think of LNG as just an LNG tank is really just a thermos. It's cryogenic. It's 260 degrees below zero, so you need a thermos bottle basically to store the fuel. Those are expensive. So the cost of putting one of those on a truck is pretty high.
Can I
Please jump in.
I think one of the fundamental assumptions that's being made across here is what the price of gas is. And I'm going to suggest natural gas. I mean, I can tell you the horror story on oil if you want it, but I think we're in natural gas discussion. By the way, diesel will never be cheaper than regular gas again, ever. Okay? And if somebody wants to talk to me about that later, but in details, there's a number of reasons why that's the case. First thing is, I'm going to a little bit on the consumption side before I come back and kind of throw some cold water on the supply side. On the demand side, if you look out in the bay here, the Washington State ferries are now considering the possibility of going to LNG. Now there's some Coast Guard problems with putting, as some of you may know, compressed gas or LNG gas underneath the compartment with residents or occupants in it. But they're going to have to resolve that. The big shipping companies are looking very seriously at LNG because of the pending emissions control area off the coast of Canada and the United States and the entire Caribbean. That takes effect on August 1st. If you're not familiar with that, I would suggest you spend some time on it. If you're a shipper, you're very aware of it. It's going to dramatically alter the bunker fuel market and the fuels market for the low sulfur diesels. So you're going to have a dramatically larger demand consumer out there potentially coming in. You add in the trucking, which, by the way, big supporters of fleet. I think you guys, again, like you, are in the sweet spot. Put a garbage truck on a natural gas feed, it's like adding 43 homes to demand. So you start adding those vehicles, start adding some ships. You go gas to liquids. Shell announced this morning that, or yesterday, I guess it was actually, that they're very seriously looking at a gas to liquids, gas to diesel facility in Louisiana. You have all the chemical companies coming back into the U.S. The biggest drop in that gas graph that he had up there on U.S. demand was a natural gas fertilizer supplier leaving the U.S. They're coming back. So the demand side of this thing is like, if you're familiar with car talk, we're going to try and cut this pie into 3 halves. So I would suggest you pay close attention to that. We spend a lot of time worrying about that ourselves. Now, real quickly on the supply side. The assumption that we're going to have sub $4 gas is wrong. If you read the financial statements of the major gas producers, and you get into the notes, you realize that if they've been telling you about $4 gas in the public presentation, in their 10K filing, they're talking about $7 production cost. Many times in the public presentation, they'll just leave out something simple like DNA, or excuse me, plugging in abandonment cost. It's a big deal if you leave that out of the well cost. The other one is what type of curve, production curve are they assuming? And that's really important because I don't want to go into a lot of detail here, but a typical shale well will decline between 60 and 80% from its initial 30-day IP in the first 12 months.